Good morning, Math 30s. We are moving on to Lesson 4 in our unit on polynomial functions and equations. Lesson 4, I'm going to introduce you to two new theorems, the Remainder Theorem and the Factor Theorem. This corresponds to page 309 in your student workbook. One thing I do want to mention, though, is I do my own class examples. So these examples that I'm going to do, the homework is going to be from Lesson 4, but these are going to be from my note package. And then at the end of this video, I'm going to solve 3 of your homework examples for you. So what it says is determine the remainder when this polynomial is divided by the following 2 binomials. So the first thing we have to do is for A, let's write out what our polynomial function is. So I'm going to call our polynomial function P of x, and this is what P of x is equal to. So 2x to the 4 minus 5x cubed minus 5x squared plus 5x plus 3. Then when we're dividing it by this binomial, what we essentially need to do is we need to figure out the root of the binomial. So if you let your binomial equal to 0 and you solve for x, x is going to be equal to 3. So what this question is actually asking us is they're saying, please solve for p of 3 for A. And what happens is when we put 3 in for x, so we're going to take our x's out and we're going to substitute 3 inside, the answer is going to be the remainder of this polynomial when it's divided by that binomial. So this would be 2, 3 to the power of 4 minus 5, 3 to the power of 3 minus 5, 3 squared plus 5 times 3 plus 3. P of 3 is equal to 2 times 81 minus 5 times 27 minus 5 times 9 plus 5 times 3 is 15 plus 3. P of 3 is equal to, so if you computed this on your calculator, you would get P of 3 is equal to 0. So what that means is 0 is our remainder. Okay. What the remainder theorem says is it says when you take a polynomial, P of x, and you divide it by a binomial. So remember when we divide it by a binomial, we need to figure out what the root is. So set it equal to 0. X is equal to A. So when I take my polynomial and I input A, whatever my output is, that is going to be the remainder. So here, when I input 3 and I got an output of 0, that's the remainder. Let's figure out what B would be. So this one, if you set it equal to 0, x is going to be equal to negative 2. So what we are solving for B is P of negative 2. So let's see what the remainder is when the binomial and what we're dividing it by is x plus 2. So P of negative 2 would be, every time you see an x, put in a negative 2. So negative 2 to the power of 4 minus 5, negative 2 to the power of 3 minus 5, negative 2 squared plus 5 times negative 2 plus 3. P of negative 2 is equal to 2 times negative 2 to the power of 4 is 16 minus 5 times negative 8 minus 5, negative 2 squared is 4 minus 10 plus 3. P of negative 2, so again, if you input that into your calculator, the output should be 45. And again, this is your remainder. So when you divide your polynomial P of x by the binomial x plus 2, if you either did long division or synthetic division, your remainder would be 45. That's the remainder theorem. This part here, so again, what is the remainder when this polynomial is divided by this binomial? So the root of this binomial is 3. P of x is equal to 11x minus 4x to the 4 minus 7. P of 3 is equal to 11 times 3 minus 4 times 3 to the power of 4 minus 7. P of 3 is equal to 11 times 3 is 33 minus 4 times 81 minus 7. And P to the negative 3 is equal, actually I'll do first down here, P to the 3 is equal to 33 minus 324 minus 7. And then P to the negative 3, if you evaluate that, you'd get negative 298. Okay, and again, this is my remainder. So let's check this using synthetic division. So remember, so this is to sort of review the last lesson. If we're doing synthetic division, we need to rewrite this in descending order of x, and I need to add in 0 for my placeholders. So P of x is equal to, so descending order of x would be negative 4x to the 4, and then plus 0x cubed, plus 0x squared, plus 11x, and then my constant at the end, which is going to be my y-intercept, minus 7. Remember that for synthetic division, your upside down division bar, and then negative 4, 0, 0, 11. So negative 4, 0, 0, 11, and negative 7 is at the end. What goes in front is going to be the root of your divisor. So the root of our divisor is 3. So that goes in front. Let's bring down that negative 4, and then we multiply. Negative 4 times 3 is negative 12. Here we add. 0 plus negative 12 is negative 12. Negative 12 times 3 is negative 36. And when we add those two, I get negative 36. Negative 36 times 3 is going to be negative 108. And here, when you add 11 plus negative 108, you get negative 97. Negative 97 times 3 gives you negative 291. If you add these two, negative 7 plus negative 291, you get negative 298. And there is that remainder, right? So negative 298, negative 298. So the remainder theorem, again, what it says is that when you substitute in the root of your binomial, that answer is going to be your remainder. So I could do this method to get my remainder, or I could have done synthetic division. Most students will prefer this method to get the remainder. Okay, let's look at this question. And then what I'm going to do is I'm going to show you how you could do this quickly on your calculator. I'm going to show you a little bit of a cheat. Okay, so which binomials are factors of this polynomial? So this is going to be the factor theorem. And what the factor theorem states is if you substitute in the root of your binomial, and if you get 0 as an answer, then the binomial will be a factor of the polynomial. Okay, so we're going to plug each of the roots into our original polynomial, and any answers that give us 0 are going to be factors of the polynomial, and this is our polynomial here. Okay, so how are we going to do this? What we're going to do, so we know that this root is x is equal to negative 1. So for a, let's write our polynomial. P of x is equal to, and that's our polynomial right there. So x cubed minus 6x squared plus 5x plus 12. So we know that we are now figuring out our divisor is x plus 1. So our a value is negative 1, right? The root is negative 1. So that would be negative 1 cubed minus 6, negative 1 squared plus 5 times negative 1 plus 12. P of -1, if you punched all of this into your calculator, actually I'll do one more step down, so that would be -1, -6 times 1 minus, that should be 5, plus 12. P of -1 is -1 minus 6 minus 5 plus 2. So let's see what we get. P of -1. That is going to be -7. Okay, I'm just going to pause this for 1 second. Okay, sorry about that. I just realized a mistake that I made. This should be a 12, and this should be a 12. Plus 12. Okay, so what do we get? -7 minus 12, or sorry, -7 minus 5 is -12. -12 plus 12, P of -1 is 0. So this is our remainder. And what the factor theorem says, so it's a special case of the remainder theorem, is if you input the root of the binomial and you get a remainder of 0, what that means is that this binomial here, x plus 1, is a factor of p of x. Okay, so if you get 0 as the remainder, then the binomial is going to be a factor of p of x. Now, I showed you how, what I explained at the beginning of this question is I'm going to show you how to do this in a really quick way. And I'll show you how you do this on your calculator. So you want to input this into y1 on your calculator. So if you take out your calculators, go to y is equal to, input the polynomial, which is x cubed minus 6x squared plus 5x plus 12. You could look at what the polynomial looks like. This is the graph of the polynomial. That doesn't really matter. What I want you to go to is your table of values, so second function table. We just inputted -1, and look at what we got as an answer, 0. So this column here gives you your remainders when this x is your input. So what I mean by that is, let's look at b. b is x minus 3. That is going to be x is equal to 3. What is p of 3? If I put a 3 in for all of these x's, I'm going to go to my calculator. I'm going to go down to 3. P of 3 is 0. So like a nice shortcut to do this, P of 3 is 0. So the remainder is 0. Therefore, this binomial, x minus 3, is a factor. Is a factor of P of x. So that's a factor, that's a factor. Let's check C. X minus 4 is the binomial, so we're checking P of 4. What's the remainder when the input is 4? If I go to my calculator, P of 4 is 0. This is also a factor. So P of 4 is 0. That's the remainder. Therefore, in order to get that 4, the binomial was x minus 4 is a factor. Is a factor. And then the last one, so that guy's a factor. Let's check D. D is going to be, my A value is going to be -4. So for D, what's P of -4? What's the remainder when you input -4? So going back to my calculator, I scroll up. The remainder when the input is -4, it's going to be -168. Is x plus 4 a factor? And the answer is no. Therefore, because it doesn't have a remainder of 0, x plus 4 is not a factor. Is not a factor. Okay? So that is actually going to conclude the lesson, the class examples for the lesson. And then right now what I'm going to do is I'm going to do with you 3 homework questions. So number 4, number 8, and number 10. And then you'll be able to do these remaining questions. Okay, let's look at number 4. So what number 4 says is it says when this polynomial, x to the 4 plus ax squared minus 16, is divided by x minus 1, the remainder is negative 14. So a few things that we need to do. And then it says, what is the remainder when the same polynomial is divided by x minus 2? So we're going to use this first line to figure out what the a value is. So my polynomial is p of x. That's my polynomial. And p of x is equal to x to the 4 plus ax squared minus 16. Then what they tell me is when I input this binomial, so the root is negative 1, when I input p of negative 1 into this binomial here, so negative 1 to the power of 4 plus a negative 1 squared minus 16, the remainder is 14. So this is equal to negative 14, okay? Negative 1 to the power of 4 is 1. Negative 1 squared is going to be plus 1a minus 16 is equal to negative 14. If I continue from here, so 1 minus 16 is negative 17. Sorry, 1 minus 16 is going to be negative 15. So 1a minus 15 is equal to negative 14. And then we're going to isolate for a, so get rid of that negative 15. And a is equal to 1. When you add 15 to both sides, that's what a is equal to. So now I know what a is equal to. So I'm going to go up here. And they tell me that a is 1. Okay, so now they want to know, well, what's the remainder of this polynomial when it's divided by x minus 2? So x minus 2, you have to say, what's your a value or what's your root? Your root is x is equal to 2. So now p of 2 is equal to, into this polynomial, we're going to put a 2 in whenever we see an x. So 2 to the power of 4 plus 1 times 2 squared minus 16. Okay, if you evaluate that, p to the 2 is equal to 4. And the question was, what is the remainder? The remainder is 4. So the remainder is 4. Okay, let's do question 8. The 3 that I'm going to do are very similar to this. So number 8, find the value of a so that x minus 1 is a factor. So remember that if it's a factor from the factor theorem, p of a is equal to 0. So if they want this to be a factor, our remainder is 0. So that's my binomial. So you have to ask yourself, okay, what is the root? So the root is negative 1. So p of negative 1 is equal to, I have to plug everything into here. Whenever you see an x, substitute it out for a negative 1. And then what this is equal to, if x plus 1 is a factor, then the remainder is 0. So if it's a factor, this has to be equal to 0. Okay? So going from here, negative 1 to the power of 4 is 1, plus 4 times, that would be negative 1. Negative 1 squared is 1, so plus a, minus 4 plus 1 equals 0. Let's get our like terms together. Actually, before I do that, 1 minus 4 plus a minus 4 plus 1 is equal to 0. Okay, so let's do our like terms. 1 and 1 is 2. 2 minus 4 minus 4. So let's see, 2 minus 8 is negative 6. So negative 6 plus a is equal to 0. Isolate for your a is equal to 6. Last question that I'll do with you is question number 10. So for question number 10, p of x is equal to the given polynomial, and then they're saying that p of negative 2 is equal to 0. So we know that x plus 2 is a factor, right? So when they input negative 2, then I know that x plus 2 is a factor. So the first thing that we're going to need to do is we're going to need to figure out what this missing k value is, right? So we need to figure out what that missing k value is. So p of negative 2 is equal to negative 2 cubed plus k negative 2 squared minus negative 2 minus 2. If it's a factor, that's equal to 0. So now let's figure out what we have over here on the left-hand side. Negative 2 cubed is negative 8. Negative 2 squared is plus 4k. Negative 2 negative 2 is plus 2, minus 2 is equal to 0. Okay, 2 minus 2 is just going to cancel. And then I'm going to have negative 8 plus 4k is equal to 0. 4k is equal to 8. K is equal to 2. Okay, so k is equal to 2. So this is a 2 up here. Now what we have to do is they want me to completely factor this. So we're going to be doing synthetic division to factor this. And let's do for synthetic division our upside down division bar. And remember, we take our coefficients when we're in descending order of x. So we're going to have a 1 there, a 2 here, a negative 1, and a negative 2. So I'm in descending order of x, and my root is negative 2. Bring down that 1, I get negative 2 here. When you add, you're going to get 0. 0 times negative 2 is 0. Add, you get negative 1. Multiply negative 2 times negative 1 and you get 2. And when you add here, you get 0, right? So this is what's expected. Our remainder was 0, which we knew about. So this is our quotient. And remember that if this is a third degree polynomial, our quotient is going to be a second degree polynomial. So this q of x is going to be, that's x squared, plus 0x, which I don't need to write, minus 1. Okay, x squared minus 1. So now, rewriting my polynomial, p of x is equal to the divisor. So remember that our divisor was x plus 2, right? So x plus 2, that's a factor, multiplied by the quotient is x squared minus 1. And this, hopefully you recognize from Math 10C, Math 20-1, this is not completely factored. This is a difference of squares. So two terms separated by a minus, both of these terms can be square rooted. So what this becomes is x minus 1, x plus 1, x plus 2. So my polynomial, completely factored, is going to be x plus 2, x minus 1, x plus 1. And one last thing I want to make sure that everybody understands, if I said, what are the roots of my polynomial? What are the zeros of the polynomial? You know that this root is negative 2, this root is 1, and this root is negative 1. So if you plugged in either negative 2, 1, or negative 1 into your original polynomial, you will get remainders of 0. These are going to be x-intercepts we'll look at in lesson 5. And that concludes this lesson.